Hello and welcome everyone in this video tutorial, or I should say second video tutorial on chapter metals and non-metals. So basically the topics which we have already covered in previous tutorial are, or I should say were, metals, non-metals, and metalloids, occurrence of metals and non-metals, physical properties of metals and non-metals. So the physical properties which we have discussed were physical state, malleability, ductility, luster, heat or thermal conductivity, hardness, tensile strength, density, conductivity of electricity, sonority, and last but not least, melting and boiling point. Okay. Today we are going to discuss about the chemical properties of metals and non-metals. So when we are having a discussion about over the chemical properties of metals and non-metals, according to if we go according to the book, all elements react and show certain chemical properties. They have depending on their nature and conditions of reactions. Metals and non-metals differ from each other due to their these chemical properties they have. So the first property which we have here to discuss is chemical properties, that is the reaction with oxygen. So in terms of metals, most of the metals reacts with oxygen to form metal oxides. Now here I use the word metal oxide, and in book it is written as basic oxide. Do not get confused, both means the same. Basic oxide and metal oxide both are same. The reason behind this is uh, when a basic solution, or I should say when this metal oxide is added to water, it gives out a basic solution. Okay, so that is the reason metal oxides are also known as or called as basic oxides. So now after metal oxide or basic oxide, there are some special oxide which are known as amphoteric oxides. Okay, uh, amphoteric oxides are those, I hope you remember the word amphibian. Amphi means both, which can show the property of both. Amphibians were those who can live on land as well as on water. So here amphoteric means those substances which behave as acid as well as base, both. So the examples here are for amphoteric is ZNO, zinc oxide, and Al2O3, aluminium oxide. Okay, and if non-metal is reacting with oxygen, if non-metal is reacting with oxygen, it will always form a acidic oxide. One more addition here is all the metals do not react with oxygen at the same rate, or I should say same speed. Metals such as sodium and potassium react so vigorously with oxygen that they can catch fire if left in open. Thus, to prevent the accidental fire, sodium and potassium are kept immersed in kerosene. Metals such as magnesium, aluminium, and zinc react with oxygen to form a thin layer of oxide. This protective layer prevents the further reaction with oxygen. Also, copper does not burn, but the hot metal is coated with the black thin layer of copper second oxide. Okay, the first activity which is provided inside your book is about to show that the metals when react with oxygen form basic oxides. Okay, what you are using here is a magnesium ribbon. Okay, and you will be burning the magnesium ribbon. After burning in the presence of oxygen, the magnesium ribbon will form magnesium oxide. This magnesium oxide MgO, when treated with water or when allowed to react with water or mix with water, it will form magnesium hydroxide. Magnesium hydroxide is a base. This magnesium hydroxide is the same thing which is used in Gelusil or Digen as an antacids. Okay, this magnesium hydroxide, or another name of this magnesium hydroxide is milk of magnesia. It is used in Digene and Gelusil, like all these antacids, to lower down the acidic value of your stomach. Uh, on the next page, you are going to find few reactions also. When you will go through the observation and conclusion in the activity, you will find that a special word, dazzling white flame. So look at the first that reaction, that is the burning of magnesium ribbon. Okay, it it is creating a very high amount of, you can say, it is very luminous. Okay, it is very luminous. Luminous means a huge amount of light is coming out of it. So that is called a dazzling white light. Okay, here in this way the magnesium will burn, and the leftover will be of something whitish color. This leftover is then mixed with water to form magnesium hydroxide. And in the bottom you will find few chemicals, or I should say few metals, and how the colors they are showing. Basically, when metal burn in oxygen, they give out color. For example, when you are burning crackers on Diwali, you get amused when some cracker gives yellow color, some gives red color, some gives green color. So this is the reason how they are able to give color, because when the metals react with oxygen, they gives light. Now the color of the light is dependent upon the nature of the metal. Here lithium lithium is giving pinkish red color, while copper Cu is giving greenish blue color. Okay, or I should say turquoise color. And potassium is burning with simple white light, and sodium is giving yellowish light. Okay, in the first reaction you are shown the reaction of sodium with the oxygen, which is releasing sodium oxide. Okay, and in another case you are watching zinc, reaction of zinc with oxygen. Now sodium is a reactive metal. Okay, if you have studied the notes which I have provided to you, you will find the value presence of sodium. The one which are at the top, they are highly reactive. The one which are at the bottom or as go down in those are very less reactive. So zinc is not that much reactive as that of sodium. So in order to for zinc to be allowed to react with oxygen, it has to be heated like magnesium. Okay, when it is heated, it will burn with a blue flame, and we will receive zinc oxide. Metals like gold are very less reactive, or we should say they are inert metals, so they do not show any reactivity with oxygen. Okay, that is the reason why ornaments or jewelry, whatever are made, they look new for a quite longer time. Okay, as I have already mentioned that when non-metals react with oxygen, they form acidic oxides. Okay, so some examples which are provided inside your book are carbon plus oxygen, that is carbon dioxide. Carbon dioxide when treated with water, carbon dioxide when allowed to react with water, it form carbonic acid, that is H2CO3. On the other hand, nitrogen when reacts with oxygen, uh, it forms nitrous oxide, which is a neutral oxide. Okay, it is neither acidic nor basic. One more thing I need to add here is this N2O, nitrous oxide, or another name could be nitrogen oxide. Uh, this gas is the same gas which is quite toxic, and if you inhale it, probably you are going to die with a huge amount of laugh, because this gas is known as laughing gas. It reacts, it do some, it is a some, it has some toxic nature which reacts with our mind, and it will make you laugh, unnecessarily laugh. Okay, the another activity which we have in your book are, is to show that non-metals when react with oxygen form acidic oxide. Okay, So the non-metal which we are using here is sulfur powder. First, sulfur powder is heated on flame. Okay, this flame, the burner, this burner is known as Bunsen burner. Okay, here this flame is produced using gas cylinder. Okay, now here the sulfur is heated. Once the sulfur is heated, it will start giving out blue color flame. This burning sulfur is taken inside this round flask. What will happen? All the oxygen will be consumed by the sulfur, and sulfur dioxide gas will be formed. This sulfur dioxide gas, when allowed to react with water, it will form sulfurous acid, that is H2SO3. Next chemical property is reaction with water. In terms of metals, most of the metals react with water to form metal oxides or metal hydroxides and release hydrogen gas. Going according to the book, metal reacts with water to form hydroxides or metal oxides and hydrogen gas. Depending on the chemical reactivity of the metals, some react with cold water, some with hot water, and some with steam. For example, potassium, on reacting with cold water, produces potassium hydroxide and hydrogen gas. That is 2K plus 2H2O gives 2KOH plus H2 plus huge amount of heat. Magnesium reacts vigorously with steam or boiling water to form magnesium oxide and hydrogen gas. Magnesium will never react with the cold water. Okay. Similarly, iron, when red hot iron, that is iron is heated and it is allowed to react with steam, then it will react with show reaction with water. Okay. In this reaction, in the bowl, in water, we have added potassium, and look at the reaction, how this reaction is happening. Zinc reacts quickly with steam to form zinc oxide and hydrogen gas. Copper does not react with hot or cold water, and similarly metals such as gold, silver, lead also do not react with water at all. Now separately one topic is given inside your book, that is inert metals. Inert metals are basically, I have already told you, that those metals which do not react. So metals such as gold, silver and platinum are quite unreactive. They do not react with anything. Okay, that is the reason why these metals are used in jewelry and are quite costly. So going according to the book, there are some metals that do not react at all with water. These metals are called inert metals. For example, gold, silver and platinum are quite unreactive. This property makes them valuable asset to be used as ornaments, decorative items or as jewelry. Platinum is also used for making electrical gadgets and international standards of weights and measure. Non-metals do not react with water. Thus, for phosphorus, water is used as a storage medium. Yes, you are hearing right. As I have just mentioned, that sodium and potassium, they are kept in kerosene oil. Similarly, phosphorus is kept inside water. If phosphorus, being a non-metal, kept outside, it will start burning. Okay. Okay, now next is reaction with acids. When we are talking about acids, when we allow metal to react with acid, we will always get salt and hydrogen gas. Whenever a metal is reacting with acid, it will release metal salt and hydrogen gas. Okay. One correction is there in book. It is listed as zinc acid. No, we are only having this metal as zinc. Okay, there is some typo error here, or I should say misprinting. H2SO4 is sulfuric acid, not sulfuric sulfate. Okay, ZnSO4 is zinc sulfate and hydrogen gas, you already know. Okay, similarly magnesium on reaction with sulfuric acid forms magnesium sulfate and release hydrogen gas. This magnesium sulfate, this zinc sulfate, these are salt, and the thing which get released is hydrogen gas. Copper reacts only with nitric acid, and during this reaction no hydrogen gas is evolved. Okay, because copper is very less reactive, that is the reason it only reacts with nitric acid. Okay, now in this slide we are going to discuss about the most important topic of this chapter, that is corrosion of metals, because in 10th you are also going to study corrosion of metal, and those who will opt for science, they will study corrosion of metal. In 12th, up to 12th, they will study this corrosion of metal. Okay, so what is corrosion of metal? Metal articles, when exposed to air and moisture for a long time, lose their luster. This is due to the reaction of metals with some of the gases in the air, which leads to the formation of thin layer of metal carbonates, metal oxides, or sulfide. The process of gradual destruction of metal due to the attack of atmospheric gases and moisture on its surface is called corrosion. So going according to your book, on prolonged exposure, prolonged means for a long time, prolonged exposure to air and moisture, most metal deteriorate or get corroded. This happens due to the reactive nature of metals. When they react with air for a long time, they form a new substance. This causes deterioration and the metal become useless. This process of metal reacting with oxygen present in the air, causing it to deteriorate. Deteriorate means बर्बाद होना, खराब होना, is called corrosion. Copper, iron, and silver are some examples of metals that corrode. Yes, you heard it right. Copper, iron, and silver. Silver, yes, silver also corrode. The silver, when you purchase the newly purchased silver, it's of whitish color, but after using it some time or wearing it for continuous prolonged time, when it reacts with sweat and the gases inside the atmosphere, it becomes blackish in color, okay, or grayish in color, I should say. So that is the corrosion. When iron is left damp in air for a long time, it gets covered with a flasky substance. Okay, flasky means flaky, or flaky means you can take out flakes from it. Okay, आप उसके ऊपर ऐसे layer उतार सकते हैं. You can take out layers from it. Okay, that is this word flaky. Flaky substance that is reddish brown in color. This substance is called rust, and the process is known as rusting of iron. Okay, this rusting word is only used for iron. Iron, on combining with oxygen and moisture, forms hydrated iron oxide or rust. Okay, similarly, copper, on exposure to damp air for a long time, reacts slowly with carbon dioxide and water of air. It loses, or I should say moisture from the air. It loses its shine as a green coating of copper hydroxide, and copper carbonate is formed on its surface over time. Okay, so for iron we need oxygen and water. Okay, that is moisture in air, and for copper we need moisture in air plus carbon dioxide plus oxygen. Okay, and this result in a green coating on the surface of the copper vessels. As I have already told you about silver, and according to a book, silver capped in air becomes tarnished and turns black over a course of time. This happens due to the formation of thin silver sulfide layer due to the action of hydrogen sulfide present in the air. Okay, now the reaction which you are watching in this is when aluminium is treated with mercury. Okay, when aluminium is getting treated with mercury, so you can see what is happening here. It is also getting corroded. So we have studied that what is corrosion. So what does corrosion do? Basically, when the layer of rust falls off, it exposes the inner surface of iron or other metals, in which a new layer of rust develops. Thus, it slowly eats away the iron objects. Iron is used widely in making ships, bridges, cars, truck bodies, etc. The monetary loss due to rusting of iron is huge. Monetary means money. We have to spend. Suppose if there is a bridge and it got rusted, so now you can't use that bridge. So now you have to replace the bridge, which means again you have to pay a huge amount of cost. So how to prevent rusting, or how to prevent this corrosion? Corrosion can be prevented by avoiding metals to come in contact with moist air. Now in atmosphere you can't ask the atmosphere to please stop sending moist air to near to my metal. So what you have to do, you have to ensure this. What we do generally is paint, grease or apply oil on the surface of metal. This extra layer will keep the metal away from air and moisture. Coating of layer of zinc on iron objects prevents corrosion. This process is called galvanization. This extra layer of zinc deposited on the surface of iron objects protects it from getting corroded. The general name which is given to such iron objects are GI objects, galvanized iron. The iron pipe which you purchase from the plumber or plumbing shops is known as GI pipes. The name stands for galvanized iron. A layer of another metal is deposited on the surface of the metal object, being protected through a process called electroplating, like on your cycle handles. A layer of chrome or nickel is coated on the cycle handles so that they become shiny as well as they don't get corroded. Next is anodizing the aluminium object by applying a uniform layer of aluminium oxide. When we apply a layer of aluminium oxide on the layer of, on I should say aluminium, any surface of aluminium, it becomes anodizing. The process becomes anodizing. Okay, this process is generally used in aeroplanes because aeroplanes are made up of aluminium and we don't want aluminium used in aeroplanes to get corroded. So this anodizing is generally used. What you should know that there is a special case in terms of aluminium oxide. When we are talking about aluminium oxide, what happens is the outer surface of aluminium reacts with oxygen and it will form aluminium oxide. Now this aluminium oxide layer will act as a protective shield for the inner metal. This shield will not allow for moist air or oxygen to get in contact with the inner metal. So this layer itself is a good thing for aluminium. Mixing some other metals or non-metals with the metal being protected through a process called alloying. Now alloying is a complete different process which is used to prevent corrosion. Okay, those who have been to Qutub Minar, they already know that in Qutub Minar there is a iron pillar which is standing there for I don't know centuries. We can't say 1 century, it is there for don't know how many centuries it is there. But this iron pillar is not getting corroded or not getting any rust. Why? Because it is made up of a certain alloy which is which prevent it from rusting. For example, the basic alloy which you have which you are using at home is stainless steel. Stainless steel. In stainless steel, some metals are added in the molten state. Molten state means when iron is melted, few more metals are added in it, and these molten metals doesn't allow rust to take place in iron. The example is that stainless steel which we are using at home.